Hello and welcome to this lecture on decision analysis, and let's jump right into it and let's talk about some basics. And of course the first question is, what is decision analysis? Decision analysis combines analytical, quantitative and visual tools to evaluate alternative choices presented to a decision maker. So whenever you do decision analysis, you typically go through 4 steps. And step 1 is you need to structure the decision problem. And that involves answering questions like what are the choices or the alternatives, what uncertainties exist, what alternatives are stochastic, what criteria guide decision making, typically profit maximizing or utility maximization. So after you structured the problem, you need to move to the second step, which is assessment and information collection. And that includes what probabilities do alternative events have and what payoff do alternative events have. Then at step 3, it gets slowly interesting. You need to evaluate the decision problem, and that means you need to conduct a systematic analysis and evaluation of alternative decision branches and ultimately determine your best decision. Then, very often, you also need to do a sensitivity analysis, which means that you need to ask yourself how vulnerable is the optimum decision to changes in the environment, and under which events would an alternative decision be superior. Okay, this all may sound still relatively vague, but those are the things that we will cover. So, as I just mentioned earlier, decision analysis combines visual and analytical tools to structure a problem. So consider the following example in a narrated structure. Okay, let's assume there is an oil company that needs to decide, shall we explore or abandon a certain project? If they abandon, that ends the project. If they explore, there's a 40% chance of positive results and a 60% chance of negative results. Then there's a follow-up decision, which is, shall you drill for oil or stop or don't drill? If you don't drill, the payoff is negative 200,000, and that basically covers the exploration cost. And if you drill, the outcome depends on initial exploration results. If you have gotten a positive result, 90%, there's a 90% probability that you find oil, and there is a 10% probability that you do not find oil. And after a negative result, there's only a 5% probability that you find oil and a 95% probability that you do not find oil. And there is a final payoff if you drill for oil, and that could be that you either find oil and then you make a profit, or you get a payoff of 600,000, and if you do not find oil, you end up with a loss of $250,000. So I was just reading that to you to illustrate that looking at a decision analysis problem in a narrated structure is pretty useless. By the time I reached the second bullet point of point 3, people already forgot, what happened under point 2 or point 1. It is therefore important to visualize a decision analysis problem. And what I just went over in a narrated structure is basically summarized in a decision tree that looks like this. So here we have a decision tree which summarizes exactly the same thing that I just went over in a narrated structure. So this is a decision tree. The first thing that you see is there are like solid dots and hollow dots. A solid dot is a decision node. That means you need to make a decision. So we need to decide, shall we explore or abandon? A hollow dot or an empty dot is a chance node. So that is determined by Mother Nature. So let's say we decide that we want to explore. We can either get a positive result or a negative result. We believe that the probability of getting a positive result is 0.4 and the probability of obtaining a negative result is 0.6. Okay, so now let's say we decided to explore and we got a positive result. Now we need to decide again, shall we drill or not drill? The same decision we need to make if we got after exploration a negative result. Well, and if we decide that we drill, there's either a probability that we find oil or do not find oil. The probability of finding oil after a positive result is, for example, 0.9, and the probability of not finding oil then is only 0.1, and the probability should be actually blue as well. So, and the same could happen if you received a negative result after exploration, should you drill, but then the probability of finding oil is only 0.05 and not finding oil is 0.95. And we have the payoff, so when we find oil, we make always a profit of 600,000. If we do not find oil, we lose 250,000. If after a positive result we would abandon or not drill, we lose 200,000. Likewise, we lose 200,000 even if we got a negative result because we had exploration cost. So the point is here that in decision analysis you first start with creating a nice decision tree, and that helps to visualize the problem in a way which is much more convenient than just reading a bunch of bullet points where the problem is explained. Okay, so let's just stop here. We should have now a pretty good overview of what decision analysis is concerned with. And then let's, beginning in the next video, let's stay with this example a little bit longer. And let's do some first preliminary decision analytic evaluations. Okay, so I'll see you in the next video.